This is section 7.3, area of complex figures. And so what we're going to talk about today is how to add or find the area of figures that have multiple shapes in them. Remember, in the last section, we talked about some basic formulas. We talked about area of a parallelogram, area of a triangle, a trapezoid, and a circle. And you're going to need to know and use those formulas. So if you don't have those, would you put all those in your notes right now, because you're going to need all those as we go through here. But what we're going to do is we're going to look at complex figures, and complex figures are ones where we have more than one shape. Look at it. We have a rectangle and we have a parallelogram together. Or over here we would have a square and part of a circle, a semicircle, in that complex figure. Or over here, if we drew a line down here, we've got a trapezoid on this side and a right triangle over there on that side. And so that's what we're going to look at. We're going to look at how do you figure out formula, or how do you figure out the area for those types of things that have more than one shape to them. Okay? And we're going to find that basically all we need to do is break that down into those particular shapes that we do know. So for instance, let's take this example. Look, we've got this pentagon. It looks like a house. And we've got enough information on it. We know that the base across here is 15. We know at least the height of the wall would be 12. And then from the tip of the wall straight up to the point on the roof, would be another 4 feet. So from all that information, we can break this down. We can say, well, look, what we've got is a square right here, or not a square, but a rectangle, and we've got a triangle right here. So that's all we have to do. So we need to find this area of the rectangle. We would simply take 12 times 15, and that'd be 180. And that would be square feet. And then we find the area of the triangle, and remember, area of a triangle is going to be 1/2 base times height. And we know the height is 4, our base is going to be the 15 again, so it's going to be 1/2 times 15 times 4, which equals 30. Okay? So we got 30 square feet for this part, 180 for this one, total 210 square feet when we're all done. So that's all we got to do, is simply break down those complex shapes into ones that are simpler. Or take this thing that looks kind of like an ice cream cone, and what we've got is a semicircle and we've got a rectangle. So rectangle, 1/2 base times height. Circle, we know that if we're talking about a circle, we've got pi r squared for our formula, and then since it's only half of a circle, it would be half of what we get for the answer for this one. Okay, so we would say, well, what we're going to get, we're going to divide that by 2 when we put those in there. All right, so let's put that in. We've got, for our triangle, our base is 11, so we've got 1/2 times 11 times the height, which in this case is 6. So that would equal 33, and we're in square meters. And if we have the semicircle, we've got pi, which we'll use 3.14, and the radius. Now, the whole thing all the way across, that would be the diameter. So we're looking at the radius, which is 3, half of it. And then we would square that. And because we only have half the circle, we're going to now divide that by 2 when we calculate that out. And so that's going to give us approximately 14.1. And if we add that with our 33, we end up with 47.1 square meters. Okay, so if you take those two, add them together. Okay? All right, your turn. Why don't you try these three right here and see if you can figure out what the area of those is. And notice that C is, you know, maybe a little bit trickier because, you know, what we're going to do maybe there is we're actually going to take away a corner. So think about that as you do that one. All right, so if we come back and we figure these out and we look at this kind of information here, we can figure out a few things from this. This is simply, you know, a rectangle and a square, I guess. They're both here. We would know that because this whole length here, the whole length from here to here is 18, and we know that from here to here is 12. We know that this last part here has got to be 6. And so now we pretty much have that figured out, and we can figure out this area. That's going to be the 12 plus 6 more, so that's going to be 18 over there. So what we have is a rectangle, which is now 12 by 18, and we have a square, which is 6 by 6. And 12 by 18, that's what, 180 and 36. 216 and 36, and so we end up with 252, if I did my math correctly there, 252, and this is square meters, or square centimeters. Okay, on the second one, you can see we've got a rectangle here, which is 7 by 15, and that's going to be 105 meters. And then we have a semicircle, and remember a semicircle is half of the circle, so we'll put a half times pi times the radius squared, so it's 1/2 times 3.14, and the radius would be half the diameter. That's 15 is the diameter, so it'd be 7.5. And if I put that in and make sure I square that term, 7.5 times 7.5 is 56.25 times 3.14, and then divide that in half, and I get 88.3. So 88.3 plus 105 gives me 193.3 square meters for that. And then for the third one, if we look at the third one, now if we didn't have that corner taken out of it, we could simply it would just be a rectangle, and we could figure it out. But since we have that corner taken out, we can do this in a couple of different ways. You could say, well, you know, that is a trapezoid and a square, so you could do that. Or you could say, well, it is that rectangle minus that little triangle. So you could do it either way. And we'll go ahead and do it with the rectangle minus the little triangle. So the rectangle across here, all the way across, is 25. And the height is 20. So 25 times 20 is 500. 500 square inches. And this triangle is from here to here is going to be 7 inches, and from here to here is going to be 5. So it's going to be 1/2 base. We'll call the 5 the base, and the height will be 7. Doesn't really matter which one you use. So 1/2 times 5 times 7, 35, divided by 2, 17.5. So now if I subtract that out, I would get 482.5 square inches. Now, you could have done that using the square, 20 by 20, and the trapezoid. And remember, the area of a trapezoid is 1/2 times the bases added together times the height. And so your bases would be the 1, would be 1/2 times base 1. If we call base 1 this one all the way across there, that would be 20, and the other one would be 13. And the height would be the distance from here to here, which would be 5. And so you could do that also. And let's just double check that, make sure that works. 20 plus 13, and then divide that by 2. And take that times 5, and we would get 82.5. This would be 400, and guess what? We get 482.5. So we could do it either way. Now, what I would like you to do before you are done is I would like you to do in your notes practice problems on page 328, numbers 6 and 7. So would you go on page 328, do 6 and 7.